All right. When we talk about exponents, this bad boy right here is called your base. And this one right up here is what's referred to as the exponent. The first type of problems I'm going to do with you guys is solve for the base. All right. And no logs here. There's no logs today. All right. Solve for the base. So when I say the base, you guys know what I'm talking about. When I say exponent, you know what I'm talking about. First thing, just like we did with radicals and absolute value, get the base and the exponent all by itself. Remove everything around it. That is your first job if you're solving for the base, which I am here. So I need to get everything out of there except for the base and the exponent. What do you think your first move is? I won't call on anybody on number 1, but I will start with 2. Add the 1 over. So we're going to add the 1 over. Negative 4x to the negative 3/5 equals 32. Still not by itself. That's not by itself means base exponent only. Got to divide by negative 4. Perfect. So divide by negative 4. Now take a look. Base exponent is by itself. Now the question is, how do I get rid of the exponent? All right, how do I get rid of the exponent? Anybody dig deep from last year on how we got rid of the exponent? Multiply, or I should say multiply, sorry, my fault. Raise it to its reciprocal. So negative 3/5, we're going to raise to the negative 5/3. Now, hey, notice I just said the word reciprocal. We do not change the sign. It's just the reciprocal. And then I do the same thing over here. It is important that you put that negative 8 in parentheses when you go to your calculator right now. So these two exponents cancel each other out. And now I go to my calculator and figure out what negative 8 in parentheses raised to the negative 5/3 is. Make sure you can do that on the calculator. And I want to help you out right now and not in the middle of the notes here. Make sure everyone can take negative 8 and raise it to the negative 5/3. Is everybody getting negative 1 over 32? You will not have to reject an answer. But again, you guys know you can certainly go to equations, plug in the original, and check to see if it comes out to be this. All right, just, hey, a heads up, because you guys have seen this. You guys have used the equations a ton this year. You're not going to get a fractions when you get the answer. It's going to be a decimal. All right, they always give you your answer as a decimal. So when you go to equations and check, just make sure negative 1 over 32 is the same decimal as what your calculator is telling you the answer is. All right, we good? We good on these type? Because now I'll start calling on people. You have to get the base and the exponent by itself. All right, let's go to 2. All right, first move here. Let's start this off right. 10. Kate, what do you want to do first? Minus 8. (9x to the 2/3 equals, what do I got there? 64. All right, next move. Richie, next move.
Divide the 9 out.
Yep, divide the 9 out. Now look, this isn't going to be pretty, right? 64 over 9. You can keep it as a fraction. That's fine. All right, I don't know what that is as a decimal, but I don't think it's going to look that pretty. Okay, if you want to put 7.111111, that's fine. I'm going to keep it 64 over 9. Base and exponent all by itself now. So again, how do you get rid of this exponent? How do we get rid of this exponent, Max?
You multiply each side by the reciprocal.
Okay, be careful. Raise it. All right, because when you say multiply, I kind of want to put it out here. So make sure you raise it to now the 3/2. Both sides get raised to the 3/2. Ask me now if there's calculator issues. How about 512 over 27? 512 over 27 for x. Anybody having any issues before I move on? All right. Before I start this one, what is the base in this problem so I know what I'm getting by itself? The entire thing in parentheses, 2x plus 3. So that's what you have to get by itself. It's not the 3. It's the 2x plus 3. So get that by itself. First move, bless you. First move. Marty?
-2.
Yep. Okay, still not by itself. Next move. Good. Kate?
Divided by 3.
Good. I'll keep, you can drop them, but I'm going to keep it in parentheses so it doesn't look like the 3 is being raised to the 2/3. All right, now it's alone. Now it's alone. So what do you want to do on both sides now to get rid of the exponent? Emma?
Subtract 3.
Ooh, not yet. Not yet. I got to get rid of the exponent.
Oh, yeah, I
Right.
got it. So would you multiply by it?
Okay. So make sure we raise everything to the 2/3. And then now, unlike the last two problems, we got a little something to do after. All right, we got a little something to do after. 2x plus 3. What do we got? 8 to the 2/3. 4. Yep. All right, we're not done though, right? We're not done. Everyone sees what we have to do next. Subtract the 3 and divide by 2. All right, so sometimes just because you're raising it to the reciprocal, you're not done. And when you have that final answer, let me know. Ones, Drew, good talk. Harper, when you're ready. What's that? You got it. Yep. All right, 1/2. Any questions? All right, one more, and then looks like we got the second type of problem today with exponents. All right, let's go. Let's roll here. First step. What do you want to do? Richie.
Add 6.
Yep. $64. Next. Good talks, good talks. Marnie, back to you.
Divide by 4.
Yes, yes. What's that? 16. Yep. Next. Page.
Multiply by the 3 over 4.
Yep. Raise both sides to the 3/4.
Oh, that's fine.
Yep, you're good. Oh boy. 8.
Oh, I'm done.
You all right?
Yeah, I just can't do addition and proof.
Okay. Small things. All right, we good. Because now I'm going to change the type of problem. So we're solving for the base. We raise it to its reciprocal. We all good. All right, now look where the variable goes. Now it's up in the exponent. And it's on both sides. So this is not a log problem. I want to do a log problem if, maybe I just had a variable there in one side. But now I got variables on both sides. So like bases, we got to get like bases. Once the bases are the same on both sides, you set the exponents equal to each other. Done. All right, but sometimes, I know on number 1, the bases are already the same, right? So now I just set 3x minus 4 equal to 2x plus 3. So if the bases are the same, you are allowed to set the exponents equal. What happens when the bases aren't the same? That's where we got to grind away today. All good? Questions? 7? All right. Number 2, now I agree. It looks like the bases are the same, but there's still some cleanup to do first. I am not ready to set the exponents equal to each other. All right, we're not ready yet. I need to clean up this left side. The right side's fine, but I got to clean up the left side to get the proper exponent. So do we remember the exponent rule when I have an exponent raised to another one? Multiply them. I got to multiply them. So this is like distributing the 2. So this is going to be 4 raised to the 2x plus 10. All right, so I needed to clean up that left side by raising an exponent to another one. And now I have the same exponent. So I could take the 2x plus 10, set it equal to 7x, and roll. Okay, now I got to go a little slower now. Actually, yeah, x equals 2. Any issues? Because I'm going to go slower now. This hasn't been no big deal today. All right, what do I do in the? Okay, you can. We're all in agreement. There's no way you're setting 2x equal to x plus 1 different bases. So you need to make them into the same base so you can set them equal to each other. All right, so now we need to talk about how do I change the bases here so they are the same. 3, I ain't getting 3 any lower. 3 staying 3. Okay, 3 is going to stay 3, can't go any lower. But that 27, I could change. And again, I want it to be a base of 3 so it matches the other side. So here's where you guys come in. I need to figure out what do I need to raise 3 to make it 27. And don't tell me 9, get out of here. All right, you're multiplying. This is exponents now. So trial and error. 3 to the what will give me 27 here. 3 to the what will give me 27. 3 to the, everyone agrees. So we'll watch though. All I did was replace 27. What is it still raised to? There you go. All I did was replace 27 with 3 to the third. The rest is still there. And now this becomes the problem we did last number 2, which is clean it up by distributing. So 3 to the 2x equals 3 to the what here? Be careful. There's always a mistake kids make with this. 3x. Yeah, they always forget to distribute it all the way to the 1. It's 3x plus 3, not 1. One job. Now you can set them equal to each other. What do we got? -3? Yeah. Anybody have any questions yet? You ready for 4? What do you think with 4? Clean it up. Forget about don't change bases. Clean it up. Right? Yep. Distribute everything. Clean this up. So this will be 2 to the, okay, going back to you guys now. 2 to the, Ariana, go ahead. 2 to the.
Second.
What do you mean second?
Oh, you
I
would
want-
change the 4.
Oh, not yet though. What I'm saying is clean this, make this into one exponent for me by distributing.
Oh.
Okay? So you raise it to another one we want to distribute. Because I just want it 2 to 1 exponent, not 2 different ones.
Okay. So it would be -9 plus -12.
Okay, there you go. Good. And on the other side, clean that up. What am I looking for there? Single exponent over there. All right, let's go. Go again.
2x minus 4.
All righty. Does everyone see why I want to clean it up? One exponent. Now we can change the base. Now we can change the bases. Am I going to get 2 any lower? Probably not. So we keep that just like it is. 2 to the -9x minus 12. All right, what's 4 going to change into? I need a base of 2, remember. So 2 squared. Again. What am I just replacing? The 4. You still have to raise it to 2x minus 4. That's a tough concept to get there. I'm only replacing the 4. The exponent still stays. Okay, got to distribute again. Two to the 4x minus 8. Now we're good to go. Okay, this one was a tough one. Take your time solving that. It is a fractional answer. How's negative 4/13 look? Darn right it does. Tough one there. Clean it up first. Clean it up, then change the base. Anything else? All right, what are we looking at for this one? Got to change the base. 2's not going any lower. Ooh, how about 32, huh? Can I get that as a base of 2? 2 to the 5th, yep. So just write 2 to the 5th, and that's in place of 32, and then still raise it to the x minus 2. Two to the 5. Oh, whoa. I got bad news after this. Sorry. Everyone's good? X equals negative 10. Okay, the bad news is I'm adding one more problem to do with it because there's one way we haven't done yet, one combination we haven't done. That'll come up on Mondays, and I want you to be prepared for it. Sorry. So here you go. Ready? 32, 2y raised to the 2y plus 4 equals 16 to the y plus 1. We haven't done this yet. The only thing we've been doing is changing one side. You might have to change both bases. All right, this is an example where I'm going to have to change. Because look, I can't raise 16 to anything to give me 32. Don't tell me 2. Right? That's embarrassing, isn't it, Sal? That's embarrassing, right? I can't. So I can't keep this 16. I can't keep this 32. I got to change them into smaller bases that are both the same. So now I got to start thinking of bases that I can raise an exponent with that'll give me 16 and 32 that are the same. Now look, stay in the wheelhouse, please. We're probably only looking, 2 to 5. If we start getting into bases of 6, 7, 8, we're probably overthinking it. All right, so let's stay in the wheelhouse of bases 2 to 5. All right, can I raise 2 to the something, 4 to the something, 3 to the something? That'll give me 32 and 16 here. So it looks like what base here? 2. It's going to be 2, yeah. Hey, you could go 4 and go 4 squared, but I don't know what you're raising 4 to get to the 32nd. Or yeah. All right, so we're going to go 2 and 2. So there will be problems where you have to change one, not just one, but both the bases. So what do you got? We said 2 to the 5th already on the last problem. Give me 32. And what about over here? 2 to the 4th? And then you got to keep trucking here. Distribute all the way. 2 to the 10y plus 20. 2 to the 4y plus 4. So there will be a couple problems probably on Monday where you have to change both the bases. Negative 8/3 look good? No?
Hold on. Maybe I'm just doing it.
Oh wait, yeah. You just need to simplify it from negative 16 over 6.
No, because I said negative 16/4. That's why.
Okay.
Not negative 4.
All right, we're good. Grant, what's your deal?
I have a Y and there's two Y's on the left side.
What?
I don't know how I have two Y's on the left side.
You need me to come over there and put you in a headlock? Get your act
I
together?
think I got it.
You sure?
Yeah, I got it
It's concerning that you don't know what's going on. You all right?
now. Okay.
I know even the great ones make mistakes,
I
right?
got
You
it.
good?
I got it now.
Okay.